Hello guys, welcome to the session. I hope you guys can hear me. Okay, let's wait for like another 2 minutes for the guys to tune in, and then we'll start the session. Like 2 minutes. Um, I hope you guys can see the screen. Um, okay, cool. Uh, okay, cool. So, in this session, what I'm going to talk is about how to prepare for programming contests in general. So right now we are focusing on IEEE Extreme because it's coming in another, I think in 1 month or so. Uh, okay, let's start then. So when it comes to uh, this programming content, it's mainly you knowing algorithms and data structures, and you have good practice in solving those problems that require algorithms and data structures. Uh, okay, it seems there's problem in the slides. Let me quickly try to fix that. Okay, it seems there's some problem that we are with the way I configure the software that we are using in screen share, because it's, even though it's Facebook Live, I'm streaming content from a software in my laptop to Facebook so that they can stream it out. But for some reason, it's cropped. So let me anyway, I can share these slides later on. Let me go through the content first, and then let's spend some time for you to ask questions if you have, because what's more important when it comes to these content is like knowing where to look for and like what to practice for. So because of that, let me just, yeah, unfortunately you'll have to like look into my face, not the slides during this session. I'll share the slides later. So so let me, okay, so okay, give me a second. Okay, okay, right, let's continue. Sorry for the issues that we had early on. Right. So when it comes to algorithms, you have to learn like quite interesting, few interesting algorithms first. If you have like, if you want to participate in contests, I hope like most of the contestants like who are participating in these contests have some interest in computer science, or like probably they are doing some, probably they are undergrads following some sort of a computer science in a computer science field. So um, so back in 1999, like USACO published a list of algorithms that people should master if they are able to win medals in IOI. So okay, probably might not familiar with the, like most of the terms that I've used here. So USACO is a computer Olympiad in USA. So they also have like some training sites to like let USA students basically to train their students. So they listed down some interesting algorithmic topics that people should master if they are like, if they want to like perform well in contests. So stuff like dynamic programming, greedy algorithms, complete search, flat fill, stuff like and shortest path algorithms like Dijkstra, and recursive search techniques, minimus spanning tree. There were like around 15 items like that that they have listed. So first thing that you have to do is like you have to learn these algorithms. So from where you can learn these algorithms, um, uh, one good there are very few there are actually right now like there are so many good resources out there, um, uh, and out of these like probably this introduction to algorithms book, which is called also called CLRS, is very famous. And there's also this book called Competitive Programming, which is also really good. and it got a lot of resources, and they have their own site with a number of problems that you can practice. And there are a couple of other sites that you can practice, of course, with tutorials like Quote versus SeARCC, and there's this thing called WCIPEG. So how to learn these algorithms? So first you have to learn this algorithm by reading text, and secondly, like just reading the algorithm and trying to like just understanding the basic concepts of algorithm is not enough. Basically you have to like practice with this algorithm, like you have to solve the problems that are used in these algorithms. So probably you have to go through past contests and find out these problems. So if you go to places like Codeforces or even HackerRank and places like almost all contest sites, like after contest they usually tag their problems with the type of algorithm they use. So for instance, like if there was a problem that is requiring the greedy algorithm, like they usually tag these problems as greedy problems. So if you say you read some text on greedy algorithms and then you want to like master it by like doing those problems, then what you should do is you just search for these tags, for in this case greedy, and get a list of these problems and try to solve problems. You might straight away like start with difficult problems or start from easy, like, and try to progress by doing much harder problems as you move on. So always like good advice is like try to do hard problems for you. Like it depends on like who you are and like what level of skill, like knowledge you have right now. But always try to do hard problems for you, so that it will make sure that it will improve yourself. Actually that's like true for like many things, not just computer programming. And while you do so while you're doing so, like by doing different problems, you will come across different variations of the algorithms that you learn. Say you, for instance, like a very good example is dynamic programming. Like dynamic programming problems have like so many different variants. So when you learn dynamic programming first, you might start with this famous coin problem, or like substring maximum matching problems or stuff like that. But likewise, there are so many different variants, like from a very simple to like very hard variants. So the way to go is basically do the problems, different problems using different variants, and try to improve yourself. So keep practicing. So these 4 steps: learn algorithm, and then do past problems and try different variants, and then keep practicing will like basically improve you over the time, and basically you learn by practicing. So one of the like key problem like people like struggle when they try to do this stuff is like they usually get stuck with problems they attempt. Like it's quite common among most of the people. So my advice for that is basically like before doing any problem, like try to first read the like if you can, like say don't attempt dynamic programming problem if you don't know anything about dynamic programming. So try to learn first at least a few things about it. But in general, like if you are stuck with a problem, so what the approach should be, like whenever you are doing problem is like basically you have to time all the problems that you attempt. So don't take a problem and try to come up with a, like don't keep thinking like for weeks trying to come up with a solution. So like time it like for at least like something like maximum 2 or 3 hours. Like if you can't come up with the solution within that time, probably you should look at the problem solution. Uh, so how to look at the solution? So the way to look at solution is basically you. It depends on like what sort of problem that is. Like say it's a problem that you attended during a contest or in a past contest. Usually, most of these contest sites like Codeverse, HackerRank, or like most of the contest organizers usually publish a text analysis, not the source code, the text analysis, like how to solve it. Even if the organizers are not publishing it, some other participant probably end up writing some, starting a discussion thread on basically how to solve the problem. And so you can read this stuff and try to understand like what the trick that you missed. Usually, what you like almost all problems. But you have to do is like you have to basically figure out a couple of tricks that that might not be obvious. So try to understand what the trick that you didn't get, and also you can look at the source codes submitted by other contestants. Usually in most of these platforms, they like it's public. Whatever you submit is public to the other contestants. So try to like look at others' code and try to understand how they did it. Like those are two different things. Like understanding trick is one aspect, and like seeing the code and like trying to understand like how they implement are two different things. Because trick is more of an algorithmic thing or data structure, special data structure they might have used. But when it comes to implementation, it can be like same algorithm. Like people can implement in 100 lines, or someone else can implement in 10 lines. So there can be like major differences like that you can basically figure out by looking at code. Okay. So that's all about like learning algorithms. That's the key part when it comes to programming contests, because it's all about algorithm problem solving. So okay, so let's come to other aspects of especially programming contests. So when it comes to programming contests, you need to, as I said, prepare. Like preparation has to be in like two forms. One is this long-term preparation that you do, and there is this short-term preparation. So the long term is like basically, as I said, like doing algorithmic problems and like practicing yourself. And then like if you are participating as a team, like for instance, this IEEE is like team-based contest where like there are three members in a team, and all three members can have their own computers, and they also have access to internet, I guess. So you have to understand this setup and like basically practice with this setup to basically maximize your performance during the contest. So if I advise, especially for IEEE-XTreme, I think so there are a few things that you have to plan out when you practice with the team. So during practice, says that you have to before starting practice, you have to basically make a few additions within your team. So to do so, you need to know the skill level of each member of your team. So there can be cases where like all three members are like solving problems alone. That's one of the setup that people can use during contests. Like, so if all three members in your team are like really good in problem solving in this contest, like whenever you like, they usually release problem sets where like each set have like, I think, at least 3 or 4 problems. So as soon as you receive this problem sets, you just can randomly get 3 problems, 3 guys picking up 3 problems, 3 different problems, and like basically try to solve it alone. That's one of ways to do it. Like, say you have 2 guys who can like code really well, but one other guy who is good at testing. In that case, it might be a case where like these 2 guys doing basically reading different problems and trying to solve these problems independently, while the third guy read all these problems and like prepare test cases, while the other 2 guys are basically code. So by the time these 2 guys end up writing the code, then the third guy can basically go there and like run a bunch of test cases and try to basically test it and submit it. So I have seen like another form of people like participate in this contest where like all 3 try to solve a single problem at a time. This can also be effective. Like, it's all depends on your team performance and like teams variations. There can be more forms that I don't know of, but these are the most 3 common forms that I've seen at least in this IEEE Extreme within my community. One of the key things that you have to know is like what each other is good at. So there can be cases where a guy is really good with some specialized area, like say computational geometry. So then it's important that this guy is doing the problem that involves any computational geometry. So if you read something that you are not familiar with, but someone else is much more familiar, you are responsible to like give it to that guy and like ask him to do it. But of course, like you need to like manage time between people, between team members, so that you optimize the score. Also, one of the good trick you can use is like using some sort of file share into like, I don't know, Google Drive, Dropbox, or I don't know, even local area network, something based LAN, Git, I don't know. So that the basic idea is you sharing all your files basically files that all your members working in a single place, so everyone can have access to it. So if you come up with like good folder and file naming structure, then you can even automate testing, right? So if you have this form where like 2 guys doing problems and third guy doing tests, or like any other form, like you can like basically collaborate well if you have better tools. So that's the basic idea behind this. Because it's, when it comes to IEEE Extreme, it's about collaboration also, not just individual performance. The final point is like have as many as practice sessions with your team. So that's something we also did those days. So we tried to so what we did was because IEEE Extreme is like anyway 24-hour contest, so we don't want to have like 24-hour practice session. Like, it doesn't make sense. So what we did was like basically we found out like some past ACM ICPC regional contests, and we timed these contests and did Like usually these contests have like 6 to 7 problems, so you can go up to 10, 11 problems. So we time it from 3 to 5 hours depending on the time availability, and we did quite a few practice sessions like that so that we can get familiar with our team also, like that helps. Okay, that's about practicing with a team when it comes to the long-term preparation. Also, it's important to note that you need to familiar with your tools in your long-term preparations, and you need to like basically optimize your workflow, right? Like you don't want so for instance, like you need to know what your ID is, like what the shortcut is that you need to use in your IDs or all stuff like that. Nowadays I think like those days what we used was like Vim and GDB, but there are like good IDs these days, like I don't know, VS Code. One of my friends said like he uses like Code these days, so there can be different, like it depends on what you prefer and what you are good at. So pick your tools well and try to be fast with these tools. And another thing that you can do is like code templates. So code templates is something like, for instance, like is something that you can use for instance, like it shouldn't be this cheating, right? So you shouldn't like write some algorithms and keep it somewhere, like use that algorithm like whenever it's needed, like. So you shouldn't cheat. So but yeah, anyway, always read the rules. It can be allowed in certain contexts. In certain cases it is not. So the basic idea of like using code templates is basically you have like bunch of predefined templates that you can use whenever you solve problems. So for instance, like C or C++, like you can define macros. For instance, like say if you have like lot of for loops whenever you write most of your algorithms and data structures, you can write a like shorthand, basically shorthand macro to make to basically write a for loop without like defining I and this I plus plus. So it's just a macro where like you write something like fr within bracket you have I and then the limit. So there can be like different stuff like that you can do, which might be useful, but always read rules. It might be against rules, so be careful with that advice. So okay, that's about tools. Okay, so let's come down to short-term preparation. Actually, like there are like really good content about this long the algorithms, the places that you can go to. I'll share those stuff after this session, so that you can get familiarized with these algorithms. So yeah, so short-term preparation. So this is, so the most of the advice I gave you for the long-term preparation were like quite generic, like you can use those stuff to participate in any contest. But since IEEE is like 24-hour contest, the short-term preparation advices are going to be like mainly for IEEE, because we kind of experience this stuff, so you might also be it might be helpful for you also, I guess. So first thing is like to take enough rest before the contest. This is a 24-hour test, so make sure that before the contest have a like long nap, Luckily in Sri Lanka it started at 5:30 am. I hope it's the same even now, so we can have a long nap the night before. Even if you're in a country which is not the case, try to have like long nap. Um, Also, it's important to have like I know like you can get stuck with problems, and like the unfinished problems can pile up over 24-hour time period. But make sure that you take enough breaks in between. That will even help you like figure out the certain techniques or tricks that you couldn't figure out. Um, but it's also like should be something calculated, because you shouldn't like take breaks whenever you want to. Like you should plan it out on when you are going to take breaks if you are like perform well, because most of the time, like IEEE Extreme, at least those days back in the day, we basically we wanted to get early lead. That's gonna help you like to end up with a good rank. So we didn't probably we took our first break after 6 hours or so after starting the contest. So anyway, like the way these guys give problem to you, like you have like they give in they release problems as in sets. So they release 4 or 5 problems, and then after another few hours another set. But it's very unpredictable. It can be unpredictable because they don't have fixed schedule, so you have to be ready to basically receive a problems at any time. Also, like you're gonna be in a place for 24 hours, so try to find a good place to be before starting the contest, and use stuff like external monitors so that you have more space to work with if possible. And also, this is important. Consider backup power and backup internet, and even backup storage, because this is really important. This happened to us because one of the times we lost power, I guess, but we had some backup, fortunately. Also, the storage, this is also important, and this is quite related to that file sharing thing that I talked about previously. So make sure your files are like synced somewhere, in case in case your hard disk get corrupted. And also try to like have some medicine or caffeine if needed, because even that, like this is like probably gonna be awake 24 hours. Then your immunity can go down, so try to be like be careful, like to have some medicine if needed. Because this is also again like with experiences we had, like in the first contest we IEEE Extreme we participated, like basically 2 of members in our team got flu in the last few hours, because like there was like flu going on during that season, and because of its 24 hours like without enough sleep, it's easy to get infected, at least in this part of the world. Also, like very interesting important thing about IEEE Extreme, I guess. So in general, like you should always like read through the problems and try to understand the problem first during the contest, and usually like you shouldn't like start coding straight away. You should like probably like plan out the algorithm and like come up with the algorithm that you're gonna implement. If you are really good, then probably you can start coding straight away, but usually the case is that you need to plan out what you are doing, probably different data structures that you want, and especially most importantly, understand that the problem itself is really important, because sometimes you end up like misunderstand the problem statement and like solving some other problem. and you will only figure that out only after submitting the code and trying to figure out what went wrong. So it's really important that you understand the problem statement really well. Usually in these contests you can ask questions from judges, and they might give you like that they might be able to like help you like figure out what the problem definition is. But unfortunately, sir, sometimes in certain problems, I'm not saying this is quite common, but this can happen where like certain problems can have like in their statement they can have like certain gray areas that you are not sure of like what exactly expected in certain edge cases. So in these cases again you can try like asking question, but it might not be that much of useful thing. In that case, only option that you have is like basically look at what other contestants do, like as in like in your judge in this scoreboard. Usually you can see like what's the scores of like other teams, and based on that you can basically make certain guesses on like whether certain things are like quite straightforward or like quite tricky for other guys. And based on that, like try different approaches and try doing certain trial and errors and try to figure out whether like what's best. There can be certain edge cases which are not fully defined with the problem statement. So in that case, you have to do trial and error and like try to figure out what's going in there. But don't resort to this approach like unless it's the last thing that you have to do. Like say you have like 3 problems in line, like you have this one problem which is giving you trouble that you have no clue of. Then try to finish with other 2 which are quite somewhat straightforward, rather than like losing points, because like for every wrong submission I think you should get negative marks, penalties. So if you are like aiming for a better ranking, you should not get these. You should try to minimize the number of wrong submissions, right? So in these cases, these tricky problems can be tricky in like in a bad way, in my opinion. So can be quite a problem, but try to handle them in a smart way. So that concludes what I actually prepared for this session. Yeah, and also like there's this. Yeah, if you have any questions, you can ask, so that I can probably help you with like anything related to programming contests, not just IEEE, anything related to programming contest, or how to prepare like even like anything related to that. It just doesn't have to be like programming contest itself. You can ask any question, and we can start the Q&A session now. Probably we can. Yeah, let's see like whether you have any questions. Okay, one of the common question people ask about programming contests is whether it's basically whether it's what are the benefits of taking part in these programming contests. Quite strangely, like at least in this part of, at least in Sri Lanka, people are not really aware of the benefits you can take out of it. And so let me just try to speak a little bit about it. So I hope it might be useful for you guys also. Of course, like winning a contest is like it's gonna give you fame, but programming contests, like taking part and winning in programming contests is much more than that. It's actually not just fame that you're after. Uh, so if you win in these contests, that means like you are really good at algorithms and data structures, and of course not just the textbook form of algorithms and data structure, but much more advanced and uh, tricky variants of these algorithms and data structures. And these are used everywhere, uh, even when it comes to research. uh, there are different variants, there are different sort of tree structures like segment trees that are used in machine learning, and also stuff like neural networks that are used in image processing. The list goes on. Like there are so many, like, because these are fundamentals of computer science, right? So if you are good at like different variants of these textbook approaches, that means like you are really in good position to like approach different kind of problems that you can come across even when it comes to research or work. So that's one thing, like, so that's why like big companies, that's one of the reason why big companies probably use algorithms and data structures. Probably is they are in their interviews. Anyway, it's arguable, like it's debatable whether it's the best approach to interview people, but at least I think that's used for last I don't know 10-15 years at least, uh, because that's the easiest and fastest way to basically find a good guy. But there can be good guys who are not good in algorithms and data structures, but it's the current practice in most big companies at least. um, and if you are like end up working at some place and gonna write some code, uh, if you want to like write efficient code, you need to be able to write different data structures most of the times. Like it's or algorithms, like it's you might need to like basically figure out where you can use a binary search to make it log n instead of instead of order n. So stuff like that can like basically produce very fast code and ultimately result in better products. And also like it's very important, like when you write code, to come up with the better data structures to represent your code base and better and efficient. And also like being able to write error-free code faster gonna help you with your work, right? So all these benefits you will get by practicing for algorithmic programming contests, and in general you can become a better programmer. So there's this question asking like how to create test cases for problems. Okay, so to answer that, I think okay. So first, you need to understand what the problem is, and then you need to basically uh, come up with different edge cases that problem can have. Usual type of edge cases are like usually look for small numbers, look for larger cases. Say, let's take a like very simple standard textbook problem where like you need to sort about list of arrays, list of numbers which is in an array, given in an array, or like I don't know, let's assume given in an array, you have to just implement this function. So what are the like edge cases that comes into mind? Like I think very standard stuff are like, what if the list is empty? What if all numbers in the array are like equal? Now say, let's change the problem a little bit. You have to sort like a given list of objects. Now comparison becomes not so obvious when it's object. So how the comparison works, different objects have equal values. So stuff like that. Also you have to look for the boundary conditions, where like what if whether like you have to consider whether it can fit into the memory, stuff like that. And also you have to consider about individual elements, whether these elements can be too small or too large. For instance, like can these numbers be like integers, or are these going to be real values? In that case, like how to represent these real values, because floating points like comparison can have like it depends on the case, like so you might need to be able to like round it up, round it down, depending on the way you have to sort. Also, like you need to know whether there can be, in case like if you end up like doing integer operations, or like general integer operations, you have to know whether there can be integer. You have to basically check whether there can be integer overflows. So yeah, those are like stuff like, say usually when you add two stuff, you need to basically check whether these two can overflow. So there are standard set of things that you have to look for. Stuff, not just the stuff that I just talked through. There can be more. You gain this stuff by like practicing and like coming across certain failures, right? But try to like come up with like over the time, try to like gain this knowledge on things that you need to look for. Again, like you can like basically you can't just read the textbooks and like figure out all the stuff. These stuff that I mentioned probably are written and well documented in most of the places, but there are certain cases that you only figure out by like failing. So again, my advice is to practice, and yeah. Okay. Okay. So there's this interesting and debatable question. What are the programming languages that you recommend for IEEE-Extreme, and the reasons for choosing them? For IEEE-Extreme, so what we used was C++, because it had this nice templates, and anyway we were familiar with C++. So one of the key reasons why a lot of people use C++ in programming context in general is STL, which is called Standard Template Libraries, and there they have like very efficient implementation of different sort of algorithms and data structures. One of the very few, one of mostly used stuff are like priority queue, which is a heap implementation. Like you ended up like there are cases that you need heaps, so in that case you don't want to implement the heap, right? So priority queue. Another would be this sort, which is a quick sort. Of course, quick sort is there in most of the programming languages. Then you have stuff like again like hash tables, common in most programming, hash maps common in programming, which is a binary. So two variants, like one is hash table based implementation, another one is binary tree based implementation. But when it comes to binary tree implementations and general binary search, in general binary tree, like they have different they have like functions like upper bound and lower bound. Where like say you have equal values in binary tree, then you need to find the leftmost and rightmost of these equal valued object. Then there are like functions to use in this STL libraries to basically get that value in a single API call. Then you have sets, which is again based on hash. One is hash set, other one is binary tree based set. Yeah, there are so many different data structures like that in standard template libraries, which can be quite useful in programming contexts. So I hope most of these are available in programming languages like Java also. But when it comes to programming communities, like most of people prefer C++ over Java probably because historical reasons and the size of the code base that you use, that you end up after programming. But then again, it's up to who you are rather than the tool that you are using. I have seen like very small. I have seen like certain contests where like both successful submissions, but one code is very small, another one is quite large. That size difference is mainly, most of the time, is caused not by the programming language but by the approach that you used. So yeah, that's all I can say about it. So there's one other question. After coming up with a solution, how to verify whether that solution is efficient enough? Okay, so the very first few fundamentals is that you need to be familiar with time analysis. I mean, like you need to be familiar with big O notation. Where you should know how to compute the time complexity and also space complexity of an algorithm that you're going to come up with. This is important because if you have the time complexity at your hand, then you can basically make a ballpark figure on like how many seconds is going to take in your computer for a given worst case scenario. So for instance, like let's go back to this sorting problem where like you are given a list of numbers, you have to sort them, and then you need to be able to figure out what the time complexity of your algorithm. Say you come up with the bubble sort, and then you need to figure out what the time complexity, which is odd n squared. Then you have to look at the problem statement and see what are the constraints. So if the constraints have like something like maximum number of elements 1000. Okay, then 1000 means like odd n squared 1 million operations in general. Like so 1 million operation in a computer modern day, like you can run it within 1 second. So also, of course, you have to look at the available time they have given for problems. So usually it's 1 second or 2 seconds or very few seconds, and look at the computer spec also. But in general, you can assume something like if you write very simple statements, you can assume something like 10 million operations per second. So in general, say you have for instance, like say you have odd n solution, and n maximum can be 10 million, then probably it's going to run in 1 second in your computer. But say n can be 100 million, probably odd n solution is not going to run within 1 second. It's probably going to be 10 seconds, and probably it's going to be time out. So you need to be able to make these calculations. That's how basically you figure out whether your solution is going to be efficient enough or not. Okay, I hope that's yep, I answered all the questions. Okay, so one last thing, you might have more questions, and Also, one thing about like Sri Lanka when it comes to programming contest, I believe like uh, we don't have a locally, we don't have very good very basically the standards have gone down over the years, I guess. So because of that, I think it's very important to give certain like encouragement and help if needed to guys who are interested working on like participating in this programming contest or learning learning how to basically solve these problems. So because of that, me and like a friend of mine, we thought of like starting a group where you guys can ask any question that you come across. If you get stuck with something, probably we can help you. And I sure so we have this Google group that I just created. So I'll just share the link to this Google group. If you are interested, just post any question that you have regarding uh, any programming contest, and we might be able to like reply back with someone in the group might be able to help you with the right direction. So I just posted it, and okay, so let's wrap up. I'll send the slides that I used, and feel free to ask any question even in this. Yeah, feel free to ask any question in this thread if you want any more information. And yeah, good luck with the upcoming IEEE contest. Yeah, thank you for listening up. Bye bye.